Rain is very important in order to supply the river, underground water sources, and regulation of the temperature. Global warming has deep impact on precipitation patterns. And if you break this cycle, the entire system collapses. So it's really important to re-establish the balance of this water cycle. The Directed Energy Research Center is part of the Technology Innovation Institute, and TIA's main mission is to address problems that the world is facing today and will face tomorrow, and water scarcity is one of these main issues. The Directed Energy Research Center, with its high-power lasers and application department, conduct research and development related to laser-based atmospheric applications. We aspire to investigate how intense laser pulses could affect the cloud mechanisms in order to trigger the rainfall by seeding laser pulses into the clouds. The laser pulses are so intense that we expect ionization of the molecules of the cloud along with acoustic waves, which will promote the agglomeration of water droplets to make them heavier, which will trigger the rainfall. We are really grateful to NCM to place his trust in us. It was possible to induce water condensation in a humid environment. If the potential of the laser is confirmed, this will be a groundbreaking advancement in rain enhancement science to improve water security and to fight against global warming effects.
Where I grew up, you walk outside sometimes and water is falling from the sky. It rains often enough that you don't have to worry about it. There are regions of the world that were never water stressed before that are water stressed now. So what is it that we can do to alleviate that kind of stress for millions to billions of people? What I study is cloud processes on the scale of an aerosol particle. I study how those particles become cloud droplets, and then how is it that those cloud droplets group together to form something that's as big as a raindrop. We study clouds in the lab because we want to understand the processes in a repeatable fashion, which is easier to do in the lab than flying around in an aircraft going 100 meters per second. You never fly through the same cloud twice. We can study the same cloud twice because we create it, and then we can vary the conditions. And that gives us more confidence in predicting whether the things we are doing are going to make it rain or make it less likely to rain. This award from UAEREP will give us the capacity to explore avenues of research that we haven't been able to really focus on previously. This is really focused on having an immediate impact and a positive difference in people's lives. We're working on things that potentially have world-changing impact.
As a small child, I was fascinated about clouds. I looked at how clouds should be to start raining. And I kept learning through the years until I'm here now. Global warming makes rain more extreme. Wet parts of the world get wetter and dry parts of the world get drier. But the little precipitation that is there occurs in flood events with larger dry spells in between. My research is about how we affect precipitation by dispersing air pollution. We would like to recognize which clouds are susceptible to rain enhancement by seeding them with specific aerosols, which are small particles that can enhance the precipitation. Once we are able to do that by means of satellite, remote sensing, radars, and machine learning, we'll be able to direct cloud seeding activities, and we will be able to understand how inadvertent seeding of clouds by air pollution affects precipitation and climate. That will allow us to realize the potential of rain enhancement to the full and get more water in the United Arab Emirates, following that everywhere else. The United Arab Emirates are leading the world research with their program on rain enhancement. Being participants in this program will advance our professional knowledge and our ability to be influential in the field for the benefit of all mankind.